Hello, ladies and gentlemen, welcome back. So the response to my last video was kinda crazy. That video was a demonstration of multipass rendering with inside Unreal Engine's Path Tracer. I got over 1,000 views in under 4 days. So I want to thank everyone for the huge response. A channel as small as mine generally does not get so many views and so much attention. So again, thank you. This video is going to be kind of a TED Talk, and I apologize for that. However, I have a lot to say on the subject because this is something I've been working towards for a very long time. Story time. I started using Unreal Engine back in 2009. However, it wasn't until 2010 when Blizzard Entertainment released StarCraft 2, the first game that they produced utilizing real-time cinematics. That was a wake-up call for me, who for the first time was seeing professional-looking animated content using a real-time cinematic pipeline. Since my background is television and film, my immediate thought was using a game engine for animated television content, such as Starship Troopers Roughnecks Chronicle, which my boss at the time, Ron Thornton, had worked on with his then company, Foundation Imaging. Foundation Imaging was a pioneering visual effects company that created the visual effects for Babylon 5, various incarnations of Star Trek, and several animated television shows like Starship Troopers The Roughnecks Chronicles. Well, at the time, Ron and our producer Scott kind of laughed at the idea. However, several years later, Ron and I were working together on an animated feature-length film for the Asylum using Unreal Engine for about 95% of the work, which proved it could be done. Fast forward to today, we have tools like ray tracing, the Path Tracer, Movie Render Queue, and of course Octane for Unreal Engine. This test has been a culmination of a lot of work and effort. I've spent a lot of time doing game engine tests. I've done a little bit of work in the milsim field and have spent a lot of time learning blueprints in order to integrate some amount of intelligent code into my content. Given the rapid development of Unreal Engine, it's very clear to me within a year or two, Unreal Engine will be a powerhouse in the television film VFX pipeline. But thanks to The Mandalorian, a lot of people now take what I have to say on this subject seriously. However, virtual production is not the breadth and width of this future. Combined with tools like Houdini, Octane, and Substance Painter, Unreal Engine will be a powerhouse in the industry for years to come. The reason why Octane was used in this pipeline was specifically because the Path Tracer does not support volumetrics at this time. Also, the Path Tracer does not have robust pass support, so any kind of tech passes you may need, like depth, normal passes, ambient occlusion, etc., would have to be rendered through Octane in order to get acceptable quality. The Path Tracer is Unreal Engine's answer to professional offline rendering. They aren't saying that the raster renderer isn't good and can't be used in this context. However, for people like me, the raster renderer doesn't cut it for live action, offline rendering type scenarios. Ultimately, I believe the Path Tracer will surpass the raster renderer when it comes to real-time rendering. However, right now, that's not its function. As you can see here, similar to Lumen, the Path Tracer contributes emissive materials to the lighting solution through global illumination. When approaching offline rendering within Unreal Engine, the first thing anyone should think about is how they're going to pass manage their shots, should that be part of your pipeline. So the first thing I set up in all my assets was a means to toggle on and off various features on each model. So in this case, things like emissive materials and lighting kits. If I jump over to this larger ship here, you can see this probably more obviously than on the Vipers themselves. So for the current version of this shot that I have rendered out, this is the means that I set up my render passes for the movie render queue. However, this could be cumbersome if you were to do this kind of shot at any great scale. So after I had posted that render, I had put some time into setting up a render manager so that I could more intelligently set up render passes in a non-destructive way. Here in the details panel, you see the different types of render passes I have set up for this scene. Currently, this render controller is set up specifically for this shot or for a production of this specific type. However, if I jump between the different passes, you don't see this update in real time. The reason for this is, for demo purposes, I had to trigger events on tick in order for this to update in real time. So we have to turn on simulate, Once we're simulating, you can see that the fill pass is selected and our skylight is turned on in the scene so that we can see all our fill and ambient lighting. If I switch to the key pass, you can see that although it's at a very low sample count, you can see the key lighting highlighting elements in the scene. If I switch to our self-lighting pass, you can see that the lights on the Viper and on the larger ship are turned on and all the other scene lighting is turned off. Same with our emissive lighting, all our emissive materials are on and interacting with the scene. However, this is only one step in the process. It's not a lengthy process. However, if I go over to the content browser and open up a master sequence, you can see here we have the sequence we were just in as a subsequence, and our render controller has been added with an events keyframe that enables us to tell the sequence what pass we are rendering. So if I hit play, we start with our key pass, we go to our self-lighting pass, our emissive pass, our fill pass, and eventually our engine lighting pass. We only need our first keyframe to set up this sequence as a render pass. Currently, the workflow is that we make duplicates of this master sequence and set up our keyframes, one per sequence, and then add them as a group to the movie render queue, where we are able to add our sequences, load a rendering profile, change our output path, where we can then save a preset of all our sequences so that anytime we make a change, all we have to do is load our preset, change the output path, or have the sequences set to overwrite, and just re-render the queue. Ideally, we'd be able to set up Octane scenes the same way. However, currently this is not a feature within the Octane for Unreal Engine plugin, and I was also having some issues getting the Octane for Unreal Engine plugin to update the animation of my VDB data, so I ended up exporting FBX files of this scene over to my DCC and render the effects from there. Right now it's hard to say if this is some kind of version mismatch between my DCC, where I saved out my Orbex files, or importing into Unreal Engine, or if this is a bug within Octane for Unreal Engine which is currently in beta. Additionally, with these specific assets, which have really large texture sets that consist of many 8K and 4K textures, this scene only renders in Unreal Engine with virtual textures turned on. Currently, Octane for Unreal Engine, as of the recording of this video, does not support Unreal Engine's virtual texture system, which will use up all my VRAM on my 1080 Ti's, and therefore won't render at all. In the future, virtual textures will likely be supported by Octane, not to mention direct storage through Windows will make the situation kind of moot. So, using Octane in this way with these assets is kind of forward-looking at the moment. However, it's very easy to see a path forward here where everything just works together without any problems. So the compositing workflow in this case was done with After Effects, although there's no requirement that you use any specific compositing package. So the first thing that we want to kind of drop into here is the pre-comp, and this is just pretty much a straight up composite and tweak, add a little bit of post effects and that type of thing to some of the elements, and just kind of get it situated into a position where further post-processing and manipulation can be applied. This is the VDB engine effect that I created with Turbulence and Octane for this render. It was cached statically so that at a later time it could be attached to an untextured version of the Viper. Theoretically, I could have textured the Viper for this scene, but at the time I didn't consider it that important. Looking back, I obviously should have done that. However, most people probably can't tell in the shot, but I can. Additionally, I set up a volumetric light for the main spotlight in the scene that backlit the Vipers at the head of the shot. One of the problems with exporting your assets from Unreal Engine via FBX to other applications is that not everything may come out the way you intend. As you can see here, the landing gear are missing. It's not that they weren't exported, but they didn't come in correctly into my DCC, and instead floated around the object as if it had been exploded. So while you can't really tell that well in the shot, the volumetric light doesn't actually cut through the landing gear as it should. And there's also only one Viper in this scene. Also, the animation for the large ship the Vipers are taking off from had the animation for the turret applied to the whole model. However, this model was zeroed out in Unreal Engine, and so I just zeroed it out in my DCC as well, which solved the larger problem. However, for a more complicated setup, you would really want to have all your animation correctly applied. I haven't explored to see if this is specific to my DCC or an overall problem with Unreal Engine's FBX exporter. However, in the future, either some kind of a Lembeck exporter or updated FBX exporter could potentially solve these issues. Ultimately, I did need the FBX exporter to handle my lens flares. In my DCC application, I was able to place lights in the scene using reference markers I had exported from Unreal Engine, so that I could get a proper track on where my lens flares were supposed to be in the scene, and also dial the intensity of each flare based on the intensity of the light. I was also able to hand key any occlusion of the source lights so that I could have the lens flares properly fall off behind objects when needed. For the sake of control, I exported my lights in separate groups so that I could have slightly different flares depending on the light source that was emanating. For the main spotlight, I decided to go heavy on the flare because we were looking directly at the light source and it was pretty close. So in the main comp I have everything layered together, but it's still at the native 2K that it was rendered at. So as a part of the last step, I up-resed everything to 4K because YouTube has higher quality data rates for 4K video than they do for anything else. Another thing that I want to talk about is the RCS system. The RCS system is a code-driven solution that I created, fires the ship's maneuvering thrusters as it's animated throughout the scene. Doesn't matter how I animate the ship through the scene, it can be done through sequencer or it can be code-driven, the system will function regardless. Additionally, I can animate the thruster firings manually through sequencer. Essentially, the system is looking at the ship's position and rotation on any given frame to get a delta value, which it uses to determine which thrusters need to be fired. There are also a number of settings I created to help adjust the sensitivity. I can also through sequencer toggle whether or not I want to fire the rotation or translation thruster arrays, which are separate in the system. When we look ahead to the coming year, the future looks pretty bright, provided that both Unreal Engine and Octane support all the necessary features for better interoperability, especially with Unreal Engine and its buffer system, which currently is very lacking. Potentially with Unreal Engine 5, the doors are going to be blown wide open on this type of pipeline. Nanite specifically looks very interesting to me because it essentially removes polygon caps in the same way that virtual texturing removed image size caps. It's not to say that either system is infinite, but really for the first time, feature film quality production can be done within Unreal Engine. Likely somewhere between 5 and 10 years from now, the path tracer itself will be real-time. Otoy already has a real-time path tracer for Octane that should be out this year called Brigade. So I know it's technically feasible for this to happen. In between Nvidia pushing for real-time path tracing, Otoy pushing for real-time path tracing, it's only a matter of time before companies like Epic also get on the bandwagon. Finally, I want to thank everyone for watching and their interest in this subject. Like I said, this is something I've been working towards for a long time, and it's finally starting to bear the fruit that I always knew it would. There's still a lot of work to do, and a lot of ground left to cover. However, no system will ever be perfect, and we'll always have reasons to use multiple applications in any given pipeline. Any and all interest in this subject helps us all. For a myriad of multimedia. And if a mood takes you, please hit like on the video and subscribe to my channel. My channel is small, I don't make any money from this, and there are no sponsors on this video. Any and all opinions that I have expressed are entirely my own. So again, thank you for watching, and I'll see you next time. Bye.